In our previous video, we have done an exercise on how to copy three of the words A, B, and C from the memory location of 2000, 2004, and 2008 to the new location 8000, 8004, and 8008 by using a register offset addressing mode. So in today's video, we're going to learn how we could further simplify the codes by introducing another addressing mode, which is called Preindex with offset. So far, we have been using three different types of addressing mode. The first one is called register in dialect. Right, we also learned about the immediate offset, and finally we also learn the register offset. So let's assume we have some value at memory address 2000, 2004, and 2008. So let's randomly assign the value, and at the same time let's initiate the register 1 with a value 2000, and maybe register 2 with 8. So for register indirect, we are moving a value from the memory. The destination is R0. The address is given by R1, which in our case, register 1 has a value of 2000. So basically, we are going to move the value from the memory with the address of 2000 into register 0. So after the instruction is executed, we should have 785634 and 12 in register 0. And for the second one, the immediate offset, we have the same data from the memory, which is given by the R1 as the memory location. However, there is an immediate offset. The value is given by an immediate value. So the address is basically R1 plus 4. So 2000 plus 4. So basically we're going to move the value from the memory location 2004 and store it into R0. So of course, after we executed this instruction, the value of R0 will be replaced by the new data. And for the third addressing mode, we're still moving data from the memory. And the address is given by R1 with the offset from the register given by R2. So if you look at our value in the registers, so R1 you still have 2000, R2 is 8. So if 2000 plus 8, so you will end up with the address 2008, and the data is 1122, 33, and 44, which is supposed to move to register 0. So if you look at these three operations for different addressing mode, the value was moving from memory to registers. So the value at register 0 is changing based on the data that we are supposed to move from memory to registers. However, the value of R1 that was used as an address pointer are still remain 2000, regardless of the addressing modes, even with the offset with immediate value or the offset with registers. And add on to the addressing mode that we have on immediate offset is called the preindex with immediate value. The difference compared to the immediate value addressing mode is the exclamation marks that you found behind the square bracket. We also can have the same preindex version for the indirect with register offset. So again, we also gonna have the same exclamation marks after the square bracket. So let's study the operation of the preindex with immediate value to see what this exclamation marks gonna do to the result compared to the normal offset with immediate value. So again, we have been looking at the value moving from memory to register 0, similar to what we have above. So, and we can find the address is given by register 1 plus 4, as what we did just now. So the register is 2004, and this is the data we're supposed to move, and we copy this one to the register 0 as we have practiced just now. The difference with preindex is after our operation, we have to modify the value of register 1 with the address that we found out just now. So after the operation that you move the value into register 0, register 1 will become 2004. So for the preindex with register offset, so we're still moving the data from the memory to register 0. And again, the address is given by R1 and R2. Register 1 is no longer 2000 because in the previous instruction, we have a preindex addressing mode which going to modify the register 1 from 2000 to 2004. So the new value for register 1 when we try to execute this instruction would be 2004 plus with the register offset, which is 8 in this case. So the value is 0x 2000 and C. So this is where the address is, and this is the data that we are interested, that we want to move or to replace the value at register 0. So remember, this is the value or the address after we add up the register and the offset. And with the preindex operation, the register 1 is going to become the new value of that we found out, which is 2000 and C. So we call this preindex with immediate offset, and this is preindex with register offset. So with that, we're going to redo the exercise that we have last video, but instead of using the register offset addressing mode, so we're gonna see how we could do the same exercise based on the new addressing mode, which is preindex offset. So we begin with the initial value that we need to put into register 0 as the address pointer to 2000, and also initiate a register 1 with a value of 8000 that we're going to use as the address pointer for the location or the destination of the memory where we need to duplicate A, B, and C to. So after we executed the instruction, so you go get. So the idea is to move the value from 2000 to a register. So let's say we were using register 2 as the middle person. Then we store the value back to the memory with the address of 8000. So after we completed the process, we're going to increase the address pointer of R0 and R4 with 4, so that in the next loop, we can automatically shift the address from 2000 to become 2004 and 2008 respectively. So first I will just load into register 2. The value comes from the memory. The address is given by register 0, which is 2000, so that I can copy A to register 2. Then I store whatever value that I put in register 2 back to the memory. However, the address instead of is 2000 is supposed to be R1, which is 8000, where I would like to store the value of R2 back to the memory location. Then I can continue the operation with R0 by introducing a immediate offset 4. So R0, which is 2000 plus 4. So basically we're going to copy the second data from the address of 2004, which is B, to register 2. And again, we're going to store whatever value we have in register 2, of course it's B, back to the memory address or memory location. The address is given by register 1 plus 4 or 8004. However, I'm going to add the preindex addressing mode to these two instructions. So after we have load the value from the memory to register 2, I'm going to modify the value in register 0 as noted by this preindex or exclamation marks to change R0 from 2000 to 2004. So after that, I'm going to store R2 back to the memory, and the address is given by R1. R1 still is 8000, so with 4 as immediate offset, so 8004 as what we explained just now. The data will go to that memory location. So with this preindex mode, so R1 will change from 8000 into 8004. So if I put a branch to the label again, if I put my label over there, so after you finish loading data to R2 and storing R2 back to the memory, the processor will jump back to your again as what you put in the label and repeat the same process over and over again Unlike the branch that we learned last week, the branch here have no condition, so it means that this is branch always. So regardless of what operation you have there, the processor will always make the jump from here back to the again and again and again. So on the third line, we load a value from memory to register 2, and we store the value from the register 2 back to the memory. The address is 2000 and 8000. In this case, we don't have the pre-index addressing mode, so the values never change. Then we go down to the fifth line, where we wrote the value from register 0 with the immediate offset of 4, which end up to be the new address is 2004. So we move B to register 2. And afterwards, with the pre-index mode, we're going to modify the value of register 0 to the new address that we just figured out, which is 2004. And after that, at the same time, we also store the value from register 2 to the new memory location, and the address is given by R1 plus 4, which is 8004. And after we move the value, we're going to change the R1 from 8000 to 8004. And after that, when your processor saw the branch instruction and the label is given by again, your processor will jump back to the root instruction there. So again, we repeat the process. R0 plus 4 is the new address. So currently the R0 is already 2004. So when we plus 4, the address is 2008. So it's where C is, and we move C to R2. So with the pre-index mode, R0 instead of 2004 will be replaced by the new value, which is 2008. Then we have to store back the register 2 back to the memory. So again, the address is given by register 1, which is 8004, which we have modified just now with 4. So the new address is 8008. So again, with the pre-index, this value will be changed from 4 to 8008. And at the same time, the data has been stored into the location of 8008. Since our task is just move these three values, 2000, 2004, and 2008, so by right we should have stopped the process instead of keep getting our processor to repeat the process over and over again. So as what we have learned in the previous video, we can use the compare. So let's compare R0 with the value of 2008. So we compare register 0 with the value of 2008, which is the last memory location that we're supposed to duplicate. And if this is true, then we're going to stop the processor from keep repeating the again. So we can have a branch with the condition of equal, which represented by the character EQ, to tell our processor if R0 is equal to 2008, let's jump to finish. So finish should be somewhere after the branch instruction, so that our processor will not go to this line anymore. So as long as R0 is equal to 2008, which is our case now, the processor found out that he's supposed to jump to finish. So of course he will continue whatever code you have down there, but the branch always will not be triggered anymore. So as you can see, with the new Preindex addressing mode, we really simplify the codes as compared to what we did last video to achieve the similar operation. There are something we could do on these two lines at the beginning, because we could not put any immediate offset for the first time, because we start with 2000, and if we have an offset 4 there, we basically tell our processor to start with 2004. So if we want to get rid of these two, another way to do it is by initializing our starting address. Instead of 2000, we start with somewhere before 2000, 4 bytes before 2000, which is 1000 NC, and also we start with 7 FFC, which is somewhere 4 bytes before the 8000. So when we come over this line, since we get rid of these two, R0, which is 1 FFNC plus 4, which is how we end up with the first word that we're supposed to copy, which is A. So F1 FFFC plus 4, which is exactly end up to be 2000. So same case with this one. After we have moved A to register 2, we are storing register 2 back to the 8000. So again, R1 we have initiated with value 7 FF and C plus 4. Again, it end up exactly to 8000 after we plus 4. So we're going to store value at register 2, which is A, into the memory location of 8000. Of course, we did have the pre-index, so the R0 is changing every time we repeat these two load and store operation, and the rest will remain the same.